All right, so we are on chapter 4.7, more equations and inequalities. We're going to talk about how to solve rational equations, solve variation problems, solve polynomial inequalities, and solve rational inequalities. All right, I'm going to pause and give you all a moment to write down the steps to solve rational equations. So step one, you're going to make sure there's only one denominator on both sides. We're going to cross multiply, then we distribute and combine like terms. And we're going to solve using inverse operations. If there's a quadratic, you may need a factor or use the quadratic formula, and then check for extraneous solutions. So basically I wrote that all grammatically incorrect. What can X not be because of the denominator? We'll fix that later. All right, so I'm going to pause. And so following those steps, here is going to be the first problem that we do. So what was our first step? Tell us to do. One denominator. So right now, do I have just one denominator? No, technically. Yes, because there's a one. So your job is to get everything linear, basically, right? So you want things to become linear. So when it says to cross multiply, that's going to help you make things linear. Does that make sense? Yeah. So if I cross multiply, that's 3x equals 5 times 2 minus x. How do we feel? And then after this, it's just now regular algebra problem, right? So we are going to distribute. And we get 3x equals 10 minus 5x. Going back to algebra 1, you want to get your variables on one side and non-variables on the other. So I'm going to add 5x. And we get 8x equals 10. And then we divide 8. And we get that x equals 5/4. Okay, then it says to check our solution. So we want to make sure that 5/4 would not make our denominator equal to 0. So if I substitute 5/4 in, would it make our denominator equal to 0? Nope. So this means that this is a real solution. It's good. It's a real deal, Holyfield. Yes, you're just making sure that it's not part of the error. All right. So you can cross multiply. Yeah. It says 3x over 2 minus x equals 5. Oh. Are we good? All right, let's do another one. So now, there we go. So now we have 6 divided by x squared minus 3 equals 3 divided by x. So when we look at this, do we have a common denominator across the board? No, there are two different denominators, right? So before you can do the other side, we're going to deal with one side at a time. So we have 6. What do you call it? 6 divided by x squared minus 3. And with that one, we want to have a common denominator. So how would I make it have a common denominator? X. He said we're gonna multiply by x squared, right? So if I choose to do that, I'm gonna multiply by x squared so they all have the same denominator. Does that make sense? So 6 over x squared is good to go. But here I'm gonna have to multiply by x squared in the denominator. And what I do to the denominator, I have to do to the numerator. For x, what would I have to do? It already has 1x, so do I have to multiply by x squared? No, just multiply by another x. So it just needed one more x. So now we've multiplied everything by x squared. And so now our denominator is the same. Once your denominator is the same, all you have to do from here on out is focus on the numerators. Okay, so we're going to focus on the numerator. So we have 6 minus 3x squared equals 3x. I can turn this into a standard quadratic by subtracting 6 and adding 3x squared. So we have 0 equals 3x squared plus 3x minus 6. And at this point, you have the choice to solve this by grouping. You can solve it by quadratic formula. Whatever your strong suit is, that's how you solve it by. Personally, I prefer to group. So if I'm going to group to solve this, I'm asking myself what multiplies to give me negative 18, but adds to give me 3. So it multiplies to give me negative 18, but adds to give me 3. Exactly. A negative 3 and a positive 6. Agree? So we have negative 3x plus 6x minus 6. So all I did was replace the 3x with something that's still true. That's how grouping works. So I'm going to group. Their GCF is 3x. Their GCF is 6. Oh, I did this the longest way possible. Why not just factor out 3? Who knows? I'll come back around. So we have 3x plus 6, and we're left with x minus 1. Mm-hmm. Now, Ms. Jones had a brain fart, and the number rule of factoring, you should always check for what? The GCF, and she did not do that. So we're going to teach you because it's a teaching moment. I should have factored out 3. And then I would have just came down what multiplies to give me negative 2, but adds to give me 1. And you would have just had to say x plus 2 and x minus 1. Which is still, did I not end up there? Yes. All right, so what can x equal? So we have x equals negative 2 and x equals positive 1. Will either one of those numbers make my denominator equal to 0? So they are good and valid answers. Yep. All right, so there are a variety of rational problems. So we're going to do is try to work through as many possible, well, a couple more, or one more, I think is all I have in here. And another one that would look like this, where you have factors in your denominator. So we're going to talk about factors. So the first thing you want to do is make sure your denominator is factored. So if I have x squared minus 16, well, x squared minus 16 equals x minus 4 times x plus 4. Because what multiplies to give me negative 16, but adds to give me 0? Negative 4 and positive 4, right? So when I'm trying to establish, so I can turn this into one denominator, this is clearly my LCD, right? My least common denominator. So what is this guy missing in order to look like that? So what is the first term missing? X minus 4. So I'd have to multiply 1 times x minus 4. What is the second term missing in order to look like this? X plus 4. So I have to multiply by x plus 4. And is this one missing anything? Nope, because that's where the LCD is. Once you have established that, all you have to do is now solve it. So we have x minus 4 plus x plus 4 equals 8. That gives us 2x equals 8. So what does x equal? 4. Now what's the problem with 4? So what's the step 5 tell you to do? Step 5, we have to do what? Check for extraneous solutions. That means that if I plug this in, will it make my denominator equal to 0? If I plug 4 into any of the denominators, will it make it equal to 0? Yes, it'll make this one equal to 0, and it'll make this one equal to 0, right? So that means that this is what we call an extraneous solution. It works out mathematically, but it's not a real solution. So that means for this problem, there's no real solution. There's an extraneous, but there's no real. Okay, so again, let's recap the types of problems you may have for rational. So here, this example is where you have to factor the denominators and then fill in the missing factors for the other terms, okay? So this is type 1 here, where you have a monomial in the denominator and you're just trying to match up the monomials, right? So we just had to match up, well, x squared is my largest monomial, so that's my least common, and you just had to match it up. And then lastly, where you just have to cross multiply because the denominator is a 1. Okay, obviously example 1 is the easier one. But we still need to be able to do the other ones as well. All right, we're gonna take a look at a word problem. I thought, yeah, okay, it's coming up. So we're gonna talk about variation. So variation, there's 2 types. There's direct variation and inverse variation, okay? When you say direct variation, it's basically a linear function, but with no, your y-intercept is at the origin, okay? So y varies directly as x. So y is directly proportional to x. So as you can see right here, it's just a linear function that goes through the origin. So that's a direct variation. That means there's some k, some constant that you're multiplying, and AKA your slope, right? But we just call it k right now because we're in variation. We're not talking about slope. Now, inverse variation. Inverse variation means y varies inversely as x. So y is inversely proportional, which ends up having us set up a proportion. So we have y equals k divided by x, which creates a rational function. Okay, and it's a rational function where you're only focused typically in the positive quadrant, quadrant 1. Okay, so directly we're multiplying. Indirectly inversely we are dividing. Directly multiply. We write it. So here we're multiplying. And here we are dividing the x. Multiplying x, dividing x. Or direct and inverse variation. It just got really cold. Oh gosh. All right, so the volume V of a cylinder with fixed height is directly proportional to the square of its radius, R. If a cylinder with a radius of 10 inches has a volume of 200 cubic inches, what is the volume of a cylinder with the same height and a radius of 5 inches? Okay, so the first thing that we need to do is establish what our equation is. So what is our equation? Well, we're talking about volume, right? Volume. So volume is a key word for equal. Do we see that? Volume is directly proportional. So directly proportional lets us know that we are multiplying. is directly proportional to the square of the radius. Okay, so it's some value, that's what the direct proportional, times the square of the radius. So that's our equation that we're working with. V equals the height I'm cold, very, very, very cold. All right, so now if a cylinder with a radius of 10 inches has a volume of 200 cubic inches, what is the volume of the cylinder? So we know that it has an R of 10. So if R equals 10 and the volume of 200 and V equals 200, can we solve for our K, our constant? Because that's what we would have to do. So this first thing we did was read. Second thing we did was create our equation. Third thing we did was identify our variables given, our values of our variable. And then the fourth thing we're going to do is solve for K. So we're going to solve for K. So we have V, which is 200, equals K times 10 squared. In order to get K by itself, we're going to divide by 10 squared. And what is 10 squared? 100. So we now solve for K. What is K? K is 2. K is just 2. Okay, so now we actually know our equation. So we now know our constant. So V equals 2R squared. That's our equation. Now that I have this is golden. I can now answer anything they ask me for. So it says, what is the volume of a cylinder with the same height and a radius of 5 inches? So I need to know, I now know that R is what? 5. So we're going to solve the problem. R is the radius. What is the value of the radius in our problem? It says radius of, so V equals 2 times 5 squared. So what is V? 2 times 25, which is 50. The volume equals 50 cubic inches. So again, first thing we do is read. Second thing is create our initial equation. Third thing, identify the given values. Fourth, we solve for our K, and we were able to write our specific equation with our K. And then 5, we were able to solve the problem. And it said, what is the volume of a cylinder with the same height, but a radius of 5? And we got 50 cubic inches. So read, equations, values, K, solve the problem. Questions? All right, we're going to try another one. So here we have the weight of an object varies inversely as the second power of the distance from the center of Earth. The radius of Earth is approximately 4,000 miles. If a person weighs 160 pounds on Earth's surface, what would this individual weigh 8,000 miles above the surface of Earth? So we read step 1, done, read. Step 2 is to make your equation. So my equation is based off what it says here. It says the weight, so W, varies inversely. So varies inversely tells me that I'm dividing. That's not how you spell dividing, guys. Pretend that it is. as the second power of the distance from the center of Earth. Second power just means squared. Does that make sense? So it's squared. And that's how we end up with our equation here. So the weight varies directly. So there's a K divided by the variable. Questions about creating the equation. Step 3 is to identify the values that are given to us in the problem. So what values are given to us in the problem? We're given our W and our distance. So we know that if someone weighs 160 pounds and the distance of that equals 4,000. It says 4,000 miles. So on Earth, which you're 4,000 miles away from the center of Earth, that's how your weight is. You're 160. So out in space, an additional 4,000 miles away, how much would you weigh? Well, in order to find that, we have to find our K. So step 4 is to solve for K. So using the information we have, we're going to solve for K. So 160 equals K divided by 4,000 squared. So I'm going to plug that into my handy dandy calculadora. So I'm going to do 160 times 4,000 squared and see what the calculator tells me. Whoa. A big old number. I'm going to switch to scientific and see what it says in scientific. So in scientific, it's 2.56 times 10 to the 9th. So the K value is 2 and 5600ths times 10 to the 9th power. Questions about finding the K? Do we understand why I wrote it in scientific? We're good. It's a really large number to write down and make sure you keep up with all those zeros, right? So it's a good thing when you have another way of writing and representing it. All right, now we're going to solve. So step 5 is solve the problem. So we're going to solve the problem. And it says, what would this individual weigh 8,000 miles away? So our problem is W equals, so the weight with your K is 2.56 times 10 to the 9th, being 8,000 feet away, squared. And that's what we're going to put in the calculator. So I have 2 and 56 times 10 to the 9th divided by 8,000 squared. I hit enter. And it gives me 4. E to the 1. So I'm going to take that out of scientific mode and go back to normal. So I get 40. Now, is this correct? Did I answer the question correctly? Let's reread the question. It says, what would this individual weigh 8,000 miles above the surface of Earth? So it says 8,000 above the surface of Earth. So do I also account for the 4,000 that were on the surface of Earth?
Yeah.
And then I have to account for the additional 8,000 above. So really, what should our distance have been? 12,000. Our distance should have been 12,000. So this would be fine if I was 4,000 additional above the earth, right? But I need to know actually additionally 8,000. So what we should have solved for was 2 and 56 times 10 to the 9th divided by 12,000 squared. Because you have to count, you're already on earth, and then you're additionally 8,000 more above it. So I'm going to be lazy and hit second entry and just change my numbers. And now I squared. I'm going to hit enter. And so in space, how much would I weigh? Or this person would weigh? 17.8-ish pounds, right? Which is why they do what? All the gravitation and how it all works. Float. So it'd be 17.8. Okay. Now, I did that to show you the importance of reading the problem fully. If I hadn't pointed that out, would you have thought that was an okay answer? Yeah, but we had to think about where that person was located. They're not at the core, they're on Earth already. So they're already that 4,000 above the Earth. And now if they're going to additionally 8,000, then you're 12,000 away from the core of Earth. Okay, so be mindful of that. Make sure you're reading and paying attention to all those little details. Okay. All right, questions. Okay, so now we're talking about solving polynomial equations. Inequalities, I'm sorry, not equations, inequalities. When you're solving polynomial inequalities, one, you want to begin by writing the inequality with all terms on one side. Okay, you want to replace the less than or equal to with an equal sign and find your boundaries for the equation. Then after that, the boundary numbers separate the number line into intervals. And you're just going to create a table and select values to determine the sign. So whether they're positive or negative. And then you're just going to identify if you're positive, because usually you're solving down to, is it greater than 0 or less than 0? If I'm greater than 0, then I'm looking for positive signs, right? If I'm less than 0, then I'm looking for negative signs. All right, ready, set, go. Or no? 3 steps. So we write the inequality with all variables on one side, with all terms on one side. So you want it to be equal to 0. That's your goal. So your goal is to either have it say less than 0 or more than 0, right? Then you want to replace the symbol, the inequality, with an equal sign, and then you're going to solve. And we're going to create a number line using those boundaries. So we're going to give it a shot. So here we have 3x squared is less than x cubed plus 2x. So I need to make one side 0, which would be the easiest thing to do. Move this guy, right? Because then I only have to move one thing. So 0 is less than or equal to x cubed minus 3x squared plus 2x. Okay, so that's what step 1 is telling you to do. All right, so step 2 is where you substitute an equal sign. So we have 0 equals x cubed. I'm going to go ahead and factor out my x. So x squared minus 3x plus 2. Why did I factor out the x? Because it's a what? Well, it's a GCF, right? Greatest common factor there. Polynomial is correct. Yes. So now I'm going to ask myself, what multiplies to give me positive 2, but adds to give me negative 3? There, switch it. All right, so it should be negative, negative. So we should end up with x minus 1 and x minus 2. Yes? Yes. Equals 0. So therefore, our x's would be x equals 0, x equals 1, and x equals 2. Okay, so these are what we call our boundary numbers. So on step 3, where it says to make a number line, you're going to make a number line and putting those numbers on the number line. So I have 0 here, I have 1 here, and I have 2 here. And you just want to know, if I take a number, a value, and I plug it in, is it going to produce a positive or a negative? So any number from negative infinity to 0, any number between 0 and 1, any number between 1 and 2, any number from 2 to infinity. So a number between negative infinity and 0, I would just choose negative 1 because it's just an easier number to plug into. So if I substitute negative 1 in to my equation right here, do I get a positive number or a negative number? So this would make negative, negative, and it would become a positive, but then there'll be a negative 1 hanging around. So then it ends up being a negative. So this makes a negative number. Okay, then what's between 0 and 1? Well, the only thing between 0 and 1 is 0.5, a half, right? So in between those two, if I plug in a half, well, a half minus 1 makes what? Negative half. A half minus negative 2 makes negative 1/2. So that's a negative, and a negative makes a negative times a negative makes a positive. So it would be a positive. Okay, what's a number between 1 and 2? 1/2. So if I substitute 1/2 in, well, 1.5 minus 1 is going to be 0.5. That's positive. 1.5 minus 2 is going to be negative. What's a positive and a negative make? A negative. Positive and a negative makes a negative. And then a number between 2 and positive infinity. 3, there we go. So that's a positive 3. What's 3 minus 1? Positive. 3 minus 2? Positive. So therefore it is positive. And I chose 3. So we're looking for, when is 0? When is this greater than 0? So when is the function greater than 0? So it's greater than 0 from 0 to 1, right? It's greater than 0 from 2 to infinity. So my answers would be from 0 to 1 and 2 to infinity. And that's how the inequalities work. Yes. I wanted to show you graphically. Do I have time to do it graphically? I don't have much time to do it graphically, but I'm just going to try really hard. Okay. So in the calculator, you would put in your function. So we put in x to the third minus 3x squared plus 2x. And then we would hit graph. So when we graph, I can't see, so I'm going to zoom in just to get a little better look. I think I pressed zoom out, didn't I? Let me fix that. And I need to zoom in. Zoom in. No, the bell. But when you zoom in, you can see where we were right. So you can see how it crossed at 0. You can see where it crossed at 1, and you can see where it crossed at 2. And I'm looking for when do I have positive values? So when am I above the x-axis? From 0 to 1. When also am I above the x-axis? From 2 to infinity. So that's how it would be looking graphically. All right. We have a quiz tomorrow.